शायद शायद है ना।
भाई कॉन्वर्सेशन वो तो फुल कह रहा है।
आज ही आ रहा है।
अच्छा
On our can you send me the POV? We'll do it on the laptop and settle down. Let's start.
थोड़ा WhatsApp हो रही है।
95349.
ये डिस्क्रिप्टिव स्टैटिस्टिक्स वाला है वो। चलो
You're sending now.
डिस्क्रिप्टिव स्टैटिस्टिक्स पे क्लिक करेगा, फिर दो तीन चीजें चूज करनी है और हो जाए।
8 बजे
करना होगा.
फिर ड्रॉप शिपिंग नहीं थी क्या?
You will extend till 5:30. Drop shipping next week.
कल कल अपने 11 स्टार्ट हुआ है।
Jab 11 started till 7.
हाँ 11 है।
Get free. It's okay. Free है.
मेरे दिन की में कुछ ऐसा नहीं. Nothing scandalous is there in my life.
तो आपको एक मेरी बास्केट में 1 केजी अनियन फ्री
गरीबी में जब घर चलाना होता है तो ऐसे ही होता है. तुम क्या मैं भी इस पे हार्ट बेच कर लिखने वाला हूँ. थैंक यू सो मच. अगर आज मैंने नहीं खरीदा तो फिर मैं बेकार आदमी. ओके, that's how it is. That's all right. आपने 1 किलो प्याज भाई धनिया मिल रहा होता है तो बात है. ओके, आई होप इट इज नॉट गेटिंग रिपीटेड. इज गेटिंग रिकॉर्डेड.
Yes.
Right. Let's start. So, very quick revision of what we did. Right. Just trying to make sure all of us are on the same page. Some of us have left the book. Pocket page.
Ajaf.
We're not in the class. Right. Please ask others to come fast. We started our discussion with the understanding of mean, median, mode. Right? Okay. We start the discussion with statistics, data, variable. What is statistics? What is data? What is variable? We also understand that anything or any summary of the data is statistic. We talked about descriptive statistic. We talk about inferential statistic. We talk about predictive statistic. We started with descriptive statistic. In descriptive statistic, we talk about the measures of central tendency, mean, median, mode. The measures of dispersion, range,
variance,
standard deviation, coefficient of
we did discuss.
Now we did not discuss. We'll discuss. In this process, we also discussed shapes, skewness, and kurtosis. This is what we have discussed. Also, we discussed a little bit about box plot, histograms, this and that, and OJIs are still remaining. Donut charts are still remaining. Now, before we move further, right, let me talk about a few things. Right, we'll come back to this data. We'll see what we do with this data. But then before we come to this data, we started our discussion with this and we talked about the kind of variables that we have. Right? So the data can either be qualitative or quantitative, all of us understand. Yes. Qualitative or quantitative. Qualitative data will be the data which is not numbers. For example, names, gender, age, income groups, not age. These are qualitative data. Quantitative data is anything which is numerical in nature. Now, when I talk about qualitative data can be of multiple kinds. Qualitative data can be nominal. What is nominal data? Nominal data is the data which is namesake data. Your names, right? This is nominal. Names are nominal. Then you have ordinal data. Ordinal data. What is ordinal data? Any qualitative data that is rank ordered, right? For example, income class, there's a rank. Right? If I talk about, let's say, religion, caste, is it rank ordered? No. Rank ordered data will be the data where one is above the other. For example, the ranks that you have in military, army, defense services, whatever, that is rank ordered, right? Assistant professor, associate professor, professor, rank ordered, junior doctor, doctor, senior doctor, chief medical officer, whatever, rank ordered, right? But then, if I talk about categories of people, surnames, not rank ordered, simple nominal data. Nominal and ordinal difference is clear. No. Either nominal or ordinal, both are qualitative in nature. This is also okay. Then you come to quantitative data. Quantitative data, okay, one more thing is, in this only, nominal, ordinal, you can have one more category which is categorical. Yes, no, binomial. Two things are possible, right? Two categories. Now you come to...
Shouldn't gender also not be in the category?
No. Categorical is also nominal. Categorical is also nominal if the categories are not rank ordered. If the categories are rank ordered, it becomes ordinal. जा रहे आप?
थोड़ा कॉल आ गया.
चलो थोड़ा नहीं पूरा आता है या तो आता नहीं थोड़ा सा आगे कैसे चलो भाई take care.
Bye.
So why भी नहीं बोला? So nominal categorical can also be rank ordered, okay? If there are two categories where there's hierarchy. Now we talk about ratio and interval. Now see, ratio is something where absolute zero means nothing. Interval is something where absolute zero also makes sense. Now this is not a clear definition. भाई साहब बोल रहे हैं हाँ भाई साहब समझ में आया आपको?
थोड़ा
कैसे आएगा? मेरे को नहीं आया बोलते थे.
जो मैं जीरो कैसे पकड़ा गया
I mean, I repeat it. Ratio is something where absolute zero makes no sense. Let's say, for example, height. Somebody's height is zero. Does it make sense? That means that person is not there. Right? Weight data. Somebody's weight is zero. Pulse, zero.
Yeah.
That means it is zero. Not there now. Right? Whereas in interval, if I say zero, somebody might say that yes, still making sense, it means something. Where absolute zero means something, absolute zero makes sense. For example, temperature. Temperature is 0 degree means what? There is no temperature or the temperature is zero. Temperature is zero is making sense. Right? Cat percentile, zero. Makes sense? It can be negative also. So interval is where zero also might make sense. Whereas
how can percentile be negative?
there will be people who will be scoring negative also. So there will be
Percentile
negative.
cat may. Okay, so you're saying the marks is total marks, total percentage is negative, whereas your percentile will be starting from.
परसेंटाइल भी नेगेटिव तो हो ही सकता है. मार्क्स से नेगेटिव है तो परसेंटाइल नेगेटिव.
Zero से start. Lowest will be zero.
चल
पुराने SAT score. अच्छा छोड़ो. SAT score. CAT score. Score. Percentile. Score. CAT score. SAT score. Possible, right? Where zero is also making sense. So ratio and interval. Now let us look at a few examples. Right?
just
Yeah, please.
ratio by definition, what you're saying, it is not a characteristic of the ratio. It is by definition, if it is not possible to have a zero value, then only it becomes a ratio.
Right. Now look at these. Right. One thing is categorical. In categorical, I told you it can be nominal and ordinal. Nominal and ordinal. Nominal is for namesake. Marital status, no up, low. Political parties, no rank ordered. Eye color, no rank order. Examples, ratings, good, better, best, low, medium, high, rank order. Discrete and continuous. When we come to numerical data, we discussed about discrete and continuous. Discrete is countables, continuous is non-countables. Discrete is something where you can tell this is exactly what it is. Number of students sitting in the class. Right now, it is
Minus 2. It's a fluid number.
Okay, but then continuous is something which cannot be measured exactly. We have discussed volume and other things we were talking about. I want you to very quickly look at a few of these, right? And tell me whether it is nominal or ordinal. Yes or no? Do you have an account on any? Is it nominal or ordinal?
Nominal.
Types of investments, nominal or ordinal? Nominal. There's no rank order in type of investment. You might like something, might not like something. Something might have what opportunity, what not is something else, but then there's no rank order there. The companies that are providing you seller services, nominal. Student class designation, years, second year, third year, and ordinal. Satisfaction, faculty rank, the institutions, the ranking that institutions and other things get, right? Grades that people get, these are all ordinal, right? Interval and ratio, let us very quickly look at the things. Temperature, what do you think? What we already talked about, right? Height, weight, age, salary. Salary is 0 means what? Right? No salary ratio. So this is okay. Now we know nominal, ordinal, we know discrete, continuous, we know categorical and other things. You know the very reason of having statistics as a subject and why you study statistics as a subject is on this slide. Not on this slide. In fact, an extension of this slide, which is this. Okay. What is this? This is the mad universe, the mad world out there in front of us, where people are doing all weird things. You'll see people doing very, very weird things if you will spend time with this. I have sat down with and looked at this for hours. I have seen multiple stories. Postmodern world here, where there are multiple truths. But one thing that you need to understand and observe here is that if this is a population, if this is a mad world out there and you want to study this mad world, you will have to spend uncountable amount of money, uncountable amount of effort and time to understand and study this world. Let's say you form a business of your own and your business is about watches and you're making, let's say, affordable watches. Now, talk about affordable watches. First thing that you would want to do before launching, before even thinking about what sort of watch will you make, is to understand what people want. That is market research. Now, when you say market research, will you go and ask every person in this world, every person in this world on what kind of watch do they like? Will it be possible? Not possible, literally, right? Not possible. If you're making a vehicle, if you're making a two-wheeler, bike, it will not be possible for you to again go and ask everyone. Making a drink, not possible for you to go and ask everyone. Then if it is not possible and you want to launch something for the entire world, how will you do it? So one thing is, it is not possible for us to get statistic on the entire population. Right? My friend today got the data for the entire class to study how the class distribution is for age. But then that was also, so how many students you have covered? All 48, right? That is also not the population for students in MU. Can I talk about students in MU on the basis of this class? MU has UG also. MU has other courses also where the students are much younger than you. There the mean age is somewhere around 16, 17, 18. I can't make any comment on their statistic on the basis of your statistic. Forget that. Can I talk about the PG students in this country on the basis of what I have in this class? Forget PG. Can I make comments about MBA students in the country? Can I make any comment about MBA students in Delhi NCR on the basis of what I have in this class? No. Why? Because this will be a highly biased sample, which is of one kind in nature. So if I'm doing that, maybe I'll end up picking all the pink people, right? All the pink people or all the people scratching their head, which does not represent the actions of other people. Are you guys getting what I'm trying to say? So you'll get one color, one action. You will not get the variety of color and actions that the people are showing here. For that, you have to make sure that you get more varied data. Now, the problem that we are facing here is that there is a bigger world out there. In this world, if I want to understand any characteristic, let's say I'm talking about the watch again. I'm talking about affordable watches. How do I make a watch that is applicable to all these people? I'll maybe select samples, right? I'll select sample from this world, varied samples, and this sample I'll say, whatever is the sample, I say that this sample is a right representative of this population. Right? Let's say I want to launch a watch which is affordable. Now, affordable can be defined in multiple ways. My affordability definition is something which is, let's say, less than 3,000 rupees. A watch which is, let's say, my definition. 3,000 rupees. Somebody might say, ऐसे गरीब आदमी affordable होता है 1 लाख. So, let's say 3,000 rupees. Now, I would want to, and then I'll see who can buy a watch for 3,000 rupees, whose family income is, let's say, this much. Right? If the family income is this much, I have defined the characteristic of my population. These are the people whom I'm interested in. Right? These are the people whom I am interested in. I'll be interested in people who have a family income of this to this, whose age is this to this, who does shopping. Let's say if I am only planning to launch it on social media platforms, so who uses social media? If I am launching it only on e-commerce platforms, who uses e-commerce platforms? If I am launching it offline, people who go and shop offline. Right? So these are the people whom I am interested in. I defined my population. Population does not mean everywhere in the world. People who are, whom I feel as interesting people, where I think that they have the characteristic that I'm looking for. That's it. Now, how do I get data from them? Now, still for me, let's say out of whatever 7 million people that you have, 7.49, whatever, the people whom I am interested in are only 10 lakhs. Still, it requires a great amount of energy and effort to go and collect data from them. I'll not go and collect data from all 10 lakhs. I'll go and collect data from maybe 1,000, 2,000, 5,000. But I'll have to make sure that these 2,000, 5,000 are from different status of life, different clusters, different regions, different groups. Right? Why am I doing this? So that I'll be able to make some inferences about the population on the basis of the statistic that I've got. So this is a sample. From this sample, I'll be estimating something about the population. That is what the whole idea of understanding statistic is. Now, अगर मेरे पास में पूरी population होती, पूरे ब्रह्मांड का data होता, if I would have had the data for the whole universe, and then I want to find out what is the mean age of this world, I could have easily equals to average. Excel will not be able to handle this. I hope you're getting the right point. But if I have the entire thing, then there is no problem at all. Because I don't have the entire thing, I'm collecting a sample. I make some statements about the sample, and then I test whether it will hold here or not. That, in order to test that, I will need some statistic. In order to test that, I'll need some statistic. I'll need some statement which can be tested. Now, the statement that I'm making to test this is known as a hypothesis. Any testable statement, easiest definition of hypothesis in this world is any testable statement. A statement that can be tested is hypothesis. Now, there are some 48 students in this class. Right now, I have only 18 of you sitting here. I don't know about the people who are online, or I will just talk to the friends who are online. I'll ignore you. I take their data, or I take your data. And then let's say I take the data of students who are in the class. Your mean age comes out. So this is the sample, the population is 48. Out of 48, I have collected data for 18 people. This becomes my sample. I find the mean age of this sample. Right? Let's say the mean age is coming out to be 21. I hypothesize. I tell you, I hypothesize that the mean age of the PGP Bharat cohort 1 is 21. I can hypothesize. Whether this hypothesis is true or not is something that has to be tested. But is it testable or not? It is 21. Testable. Very much testable. That is your hypothesis. Any statement made on the sample which is testable is your hypothesis. That is the whole idea. Why am I not doing it for 48 people? बहुत ज्यादा मेहनत है. एक एक आदमी अनम्यूट करके बोलेगा मैं जब तक बूढ़ा हो जाऊं मेरे बाल सफेद हो जाएंगे तो मैंने नहीं किया. But that's what I'm trying. Got the point right. Now, so statistics is not only about crunching numbers. In fact, I don't believe that statistics is about crunching. Statistics is more about logic. Statistics is more about process, whether you are doing things in the right manner or not. And the first step in that process is defining population by characteristic. If you have failed in defining your population, my friends, your business will fail. You have made something which you are selling to someone who's not interested in what you are selling. मैंने एक टी-शर्ट ब्रांड बनाया. मैंने बोला कि ये टी-शर्ट ब्रांड जो कि which will make you look. There are t-shirt brands which are making you look thin now, more fit, right? Now I say, who is this for? This is for people who are overweight, who have a, what is this?
Beer belly.
Beer belly.
Beer belly.
Sorry?
Beer belly.
Beer belly. BMI पूछ रहा था मैं.
25 plus. 25 plus.
BMI above 25. This is for them. I launch my t-shirt. Oh, I might be sounding correct. I am making a t-shirt which will make you look fit. It is for people who have a BMI of above 25. I launched the t-shirt. Nobody, I find, I go through all the clinics and people who are obese and all. Doctor, how many patients you have had with BMI 25? Will you sell the data? Doctors are selling the data under the table. Give me 5,000. This is what is happening in the market. You've got the data. You launch a t-shirt. You're calling these people, will you buy my t-shirt and all? And this person is like, don't call me ever again. Why? You have missed out on a few things. Might have, right? You're making a t-shirt which is for making people look fitter. You have not talked about what age range, what age. Your product is X price. You don't even know what is the price that these people can afford. You have to go deep and you'll have to think about what are the characteristics that my customer will have. So whenever you're making a product, request is close your eyes, sit down and think who all will wear this. Don't only think about how the person will look. Also think about who is this person? Where is he coming from? Is he a college kid who is going to gym and started going to gym right now and will be wearing this for some time? Only for 5 months, 4 months till the time he actually gets in shape. Should I approach to the gym people and ask them to sell this t-shirt to make them look fitter? Maybe. Should I sell this to places where they make people do Zumba and cardio and all? Should I sell it on offline stores just like that? Answers may differ, but then it depends on what you are thinking for your product. Are you getting what I'm trying to say here? Once you have very well defined the population, look for these people only. Look for these people only and collect samples. One major problem that people do while collecting sample is they use wrong strategy and wrong methods of sampling. Now sampling methods come in the picture. Can you name one sampling method which all of us have been accustomed to, have heard about since our childhood and has been drastically wrong since
Primary
ages?
data collection, primary research.
कहाँ पे? कौन सा? एक ऐसा स्पेसिफिक है जो हमेशा गलत होता है, सबसे घटिया है और हम बचपन से देखते आ रहे हैं.
Census.
सर्वे कौन सा? सेंसस तो सैंपल नहीं है. Census is population, by the way. Collecting census. What does census mean? You're collecting data from each household, everybody in the entire country. So that is population data.
But it is actually sampling. वो एक के पास जाके पूछते हैं कि आपके आसपास कितने रहते हो.
नहीं.
Population पे data ले रहे हो आप, गलत तरीके से ले रहे हो. So let's not get there. Census might be there are loopholes and problems and all where they go to the head of the family, who all are there in your family and all they ask. But then still,
Exit poll.
a friend of mine has written a book. Exit polls actually correct. I was about to tell you about a book that my friend has written, Who Moved My Vote? I have the copy. There, forget about the book. Exit polls. Have you ever come across an exit poll which has been absolutely correct? क्या problem होती है exit polls में? How? Why do you think these are not efficient, not correct?
People don't tell what
People are vocal.
First problem is people won't tell social desirability bias. I know that in this class everybody loves political party A. I am a political party B follower. But now because I have to stay in this society, everybody's saying A, 5 of your people are standing there and like, किसको दिया? कैसी बात कर रहे हो? A? Oh, I might have voted for B. One thing. Second problem is clusters. Taking data only from specific kind of people, specific income group, specific region. Data, region, cluster, problem. You're not going to urban areas. You're having your reporters sit in some semi-urban or urban area. Nobody's talking about rural areas. You're not knowing how people have voted in the rural areas. How will you tell about the entire country who is going to get how many seats? Right? You are collecting booth-wise data, and on one booth, 2 booth, you are predicting what is going to happen in the entire region. Again, a problem. Right? These are all problems with the exit poll. Now let us come back to the watch. Okay, one thing is clear. You have defined your customer. You know your customer very well. You know how to reach out these people. You are releasing social media campaigns. Whoever is watching that campaign, somehow you get their information and all, and you release a survey for them. Let's say you're talking about a very specific product. Now you're talking about luxury watches. Luxury watches. Watches which are above 10 lakh rupees a piece. Right? How will you find these people? How will you find these people?
Casino.
Casino?
नहीं, like
Annual income greater than a certain.
Annual income greater than this, that and all. Now, while you are doing that, while you are collecting annual income data and going to casinos and getting drunk, not collecting data, what I'll do is, I'll find one person who is rich, who has a lot of money maybe, and I'll ask him, do you have a watch which is above this? I don't know, but I don't have, but I know somebody who has. Now, if I find one person, there is a high chance that people who wear, let's say, expensive Rado or whatever, they'll be knowing more people in that group. So, I'll be going from one to the other. This is snowballing. Snowball. You must have seen how, right? So, you get 1, 1 to 2, 2 to 4, 4 to 8, 8 to 16, snowballing. Then there is something known as judgment sampling also. There are 2 ways of sampling. One is mathematical ways or numerical ways of sampling, and there is non-numerical ways of sampling. Probabilistic, non-probabilistic. Probabilistic sample is random sample. Random sample. Let's say I want to talk about height data in this class. I randomly pick people. You tell me your height, you tell me your height, you tell me your height, you tell me your height. Random. Does not matter whom I am picking. Randomly I pick 7 people. I will take their height and I will talk about this class. Random sampling. Random sampling is probabilistic in nature. Everybody has the probability of getting picked. And the probability of getting picked is equal. Guys agree? Systematic sampling. I'll pick every 4th person, but I don't tell where I'll be starting from. Till the probability of everyone getting picked is same. Till the time I don't decide that I'll be starting from him or her. Or him or her. Right? Then there are non-probabilistic methods like judgment sampling, convenient sampling. Judgment sampling is, I think this person will be the right sample. I pick him. Right? Exit polls and all. Where you think that this person is the right sample. I think that if I'm collecting data on, let's say, how do SMEs behave in market which is turbulent? Small and medium enterprises, let's say a technical enterprise which works on making technical products. Let's say any tech product, let's say screens. A company that is making screen is facing a lot of turbulence in the market because the tech is changing too fast. A lot of new innovations are coming in all. Now I know that there's a company that makes this screen. I'll go and take data from them. I know that there's another company. I'll go to BenQ, I'll go to any other company which is making screens and all. I'll take data from them. Judgment, pure judgment. Convenience sampling. Convenience. I want to understand the ride sharing behavior in this country. I'll go out, People are standing on the road. I'll ask them, are you okay sharing? I want to release a new, let's say, shared ride app. I'll just ask these people, whosoever is easier to find, convenient to find, I'll start with them. Snowballing, we have already discussed. You go to one person and then he gives you contact of someone else and so on. These are all ways of sampling. Sampling. Cluster. You are launching a insurance app, insurance company you're forming. Now, when you're forming an insurance company, what is the most important data for an insurance company? Let's say you're talking about auto insurance. Yes, as in what?
Number of accidents ratio.
Clearance ratio comes after the number of accidents. I will decide your premium on the basis of your driving behavior. There are new models coming up these days. Pay per kilometer and all. How much you drive on the basis of that the premium will be. People who are driving less, there's a chance that there might be less accidents. People who are driving more, there's a chance that there'll be. Now you think, let's say you think that I come up with a new insurance product where I say I'll give you insurance on the basis of the region also. Now on the region, what all are you looking at? You're looking at number of cars. अब गुड़गांव में गाड़ी ठुकने का चांस ज्यादा है, जैसलमेर में नहीं है, गाड़ियां ही नहीं चल रही है रोड पे, नहीं ठुकेगी. यहां बाहर निकलो, गाड़ी सुबह जाती है, शाम को आती है. So, getting what I'm trying to say. Let's say you think of this. Nobody has thought about this. Where are you driving the car? And I'll fit a GPS in your car. If your GPS says that you are in a red zone, in my understanding, the premium will be high. If it's a green zone, the premium will be low. People who are in Jaisalmer are happy about it. People who are in Gurgaon are not buying your insurance because yours will be expensive. Now you want to launch this, right? You want to launch this. Where did we start this from? I forgot. We were talking about sampling. We were talking about. Go on, tell me.
Non-probabilistic.
Non-probabilistic and clustering. Very good. Somebody's paying attention. We were talking about clustering and strata. Now, you form clusters in the entire country on the basis of the regions. And these clusters will be red, green, blue, yellow, whatever. These are the clusters, right? If you are in the hilly region, right, you talk about a cluster which is very, very risky, let's say. So you are doing this on this region. One. Second is you're talking about the person also. So you form stratas. In the country, there are people who will be termed as safe drivers, unsafe drivers or little risky drivers, reckless drivers, absolutely. So you go to all the, nibbas and this and that and all, chapris, whatever. Right? You're seeing what people are doing. Where do they come from? What are the things that they're doing? Right? What are they into? Somebody who is into actually doing stunts and all on car, you would not want to give insurance to that person. So you're from stratas in the data, ranks, orders. This is the safest, this is least safest, less, least, and all. These are stratas. So stratas and clusters. Stratas and clusters are clear. This is how you're collecting data. You're collecting data. There will be a few things which you'll have to be very, very careful about. There are 7 kinds of biases in sampling. Please write. This is your assignment to go and read about biases in sampling. Biases in sampling. I'll also share. Who will remind me? I'll share a reading. Reading on biases in sampling. Right? Just like I told you about one, social desirability bias is one. There can be more. What biases can creep in when you talk about sampling? Okay. Very quickly, one thing is we have talked only about primary data. You must have heard about primary and secondary. Primary data is data that you collect directly from the source. Right? Secondary data is the data that you are using. Right? It may be on the population. If I have taken data from him, which he has populated on the class, for me that becomes secondary. He has taken it from LMS or anywhere, still secondary. If I would have asked you all for the same data, your date of birth and your age, for that would have been primary. Okay? Primary and secondary, judgment convenience we have discussed, systematic cluster, stratified random sampling we have discussed. Now, we have discussed about the data, we have discussed about these things, we have discussed about Oxford have, yes sir.
Standard deviation वाली slide पीछे चली वो n-1 क्यों था आपका?
Ah, sorry. Very good. Thank you so much. Very good. Very good. Very good. इसमें you need to find the difference on the slides. Okay. Let me see if I have the formula somewhere else also. Right. कितने वाला population में n आएगा और sample में n-1 आएगा? Very good. Can you tell the reason also?
This is the error term when you take, like, it accounts for the error of the difference between the sample and the population. Like,
Yes.
because when you take a sample out of a population, there will be outliers in the population.
Possible. Not. So let's say what he's saying is accounting for the error, accounting for everything that can go out of your hands. Let's say the mean age of this class is 22. Mean age is 22, right? Now I take a sample of 5 students. 1, 2, 3, 4, and 5. I take a sample of 5 students. I tell you that I keep one student with me. I will not allow you to choose this student. This I will keep with me. And I allow you to choose any 4. That means if the sample size was 5, you are getting to choose how many yourself? 4, which is minus 1. If n is the sample size, I keep 1 with me and I allow you to choose n-1, which is your degrees of freedom. That is the freedom that you have got. Now, why am I doing this? I say that my sample will be a representative of the population and this will be absolutely equal. Somewhat way. If the age of class is 22, I say the age of class is 22. You choose any 4 students. The 5th student I will tell you. And I will make sure that this is equals to, the mean of this is 22. Now, the age of these students is ranging from 19 to 36 is what he told me. Now you give me any number between 19 to 36.
22.
20?
Mean okay. 28.
28.
32.
32.
25.
20. 19.
हमारे
25.
38.
What is the sum?
मीन कैसे बनेगा फिर 22?
82.
नेगेटिव हो जाएगी.
What is how?
ये negative.
What is the sum?
7.
107. If I had to follow this, what should have been the sum for all 5 numbers?
110.
If I tell you that the last student is 3 years, if I tell you it is not in the data, okay, because we have selected a data which is biased. This is not a random data. We have selected data which is more on the higher side. That's why it is coming out to be this. But if I tell you that this age is 3, the sample statistic will be exactly equal to the population statistic. That is why whenever we say that we are talking about the sample, you will see 2 formulas. Whenever the formula is for population, you will see n here. But whenever you will see it is for the sample, you will see n-1 here. Because whenever I am letting you choose the sample, I say that your degrees of freedom is n-1. I am keeping 1 degree with me to make sure that I am able to reach there. I am not letting you choose all the 5 yourself. Now, you have chosen these people, let's say, from this population, right? This is n. Whatever n it is. One way of choosing is this, another way of choosing is this, another way of choosing is this. You might choose only 2 people, you might choose 20 people, you might choose whatever. Go back to the concepts and remember when I told you mean has a problem. Problem is outlier, 1. Second is the lower the number of sample, the more erratic is the behavior of the mean. Right? I need to control for this also. How will I control for this? By cancelling out things maybe. Now I say, okay, you've chosen this. I am only giving you freedom to play with this number. Because if this is less and if this is an outlier, things will go out of my hands. To make sure that things remain in my hands. The thing remains with, we are able to reach to the sample. Ultimately, what is happening? This sample is a representative of the population only. बाहर से तो नहीं आ रहा है तो इसी का ही बच्चा कहीं ना कहीं. So if it is getting represented, it should behave like this only, right? Take an example where, let's say, kids, right? The parents keep control on kids. Kids can do whatever. Parents keep some degrees of freedom with them. Tomorrow, if you start behaving in an erratic manner, I know how to get you back to the normal. Parents are keeping 1 degree of freedom. घर से निकाल दूंगा. Let's say that is the degrees of freedom. मारूंगा, whatever. So that is what we are also doing to make sure that the sample is still acting as a representative of the population, and you don't end up doing this where, let's say, if you're saying the range is from 19 to 36, there was only one student who was 36. Otherwise, these students are from 19 to, let's say, 28. You take this, and because of this, now we are saying that this sample can never be a part of this population. Possible? If I take somebody who's 36 and then I look at the sample and say, ये कैसे हो सकता है? ये तो बहुत ज्यादा हो गया. ये वाला तो बच्चा बाहर से आएगा ही नहीं अब तो. I am just having it with me to make sure that I can still make it look like what it should be. That is why I said the degrees of freedom have gone down by 1, where I let you choose only. So let's say if you are having 20 numbers, I let you choose only 19 numbers.
So the summation is also done for 19 numbers?
Yes. No. Summation is done for all the 20-25 numbers that we have.
What essentially n-1 is doing is increasing the standard deviation by a slight percentage.
Absolutely correct.
So that 68% of the people can come inside that particular.
Absolutely correct.
That's it. That's
Right, sir.
the game.
Right, sir. Because you're decreasing the denominator and your score, when you root it, it will be decreased still, and that's why it will be, the standard deviation is increased, so that you're saying that the range has gone up, and the 36 who was outside will also be included, or whatever was outside will be included, because now you are actually extending your arms. Yes, sir.
What if the 22 was 27 and the total of these 4 was more than 110?
Oh, then it would have been negative. It can go to negative. It can be negative infinity to plus infinity. It does not mean, see, now one logical thing that comes to our mind is, what are you saying? How can age be negative? When I say I'm holding it with me, I am doing whatever I can do with that. It does not really have to be in that specific range where my data is. Okay, thank you so much. Otherwise, you would have missed this. Okay, so till this point, things are good. How many of you are not feeling happy? Nobody is feeling happy. I can look at your face and tell. Are you feeling happy? Huh? I don't think anything. Right. We still have some 40 minutes. We can do 2 things. One is we can look at Excel. Another is I can just complete the pictorial representation and then we move to Excel. What should we do?
Whatever you want, sir.
Paste karo. Okay, let's do one exercise. Come on, hands up. Follow me. Right? Good. Feeling better? Those of you who have water, have water. Those of you who don't, is there anyone who needs water? Water. Pani. Nobody needs it. Fine.
5-minute break.
That should be normal. Normal at this point.
Normally चाहिए. अब ये 5-minute break. अब ये ले लो.
5-minute break.
No break. अभी ये break ही तो चल रहा था. और क्या ये सब किया था देना. I bring my own. You've heard about this brand?
Yes.
What is it?
Smell.
I won't let you smell. No, I'm writing the case on.
थोड़ी स्पिरिट डालते क्या सर जिनी तो भी दे
I am writing a case on them, and it is mostly for. So there's a very beautiful and interesting story. Entrepreneur going back to the roots. Right. So इसमें क्या हुआ था कि the entrepreneur's name is Mayur Hazarika. He's from Shillong. I know him personally. I was in Shillong. He used to come and visit and all. And I've been following his journey since long time. Now they've released a variant also. Yeah. So he came for something to IIM Shillong once. I was the chair then. I was placement and student affairs chair there. So he came and we were discussing something, and he started telling me his story that I was in Gurgaon. He's still in Gurgaon. His head office is in Gurgaon only. He stays on the coast road somewhere. He's saying I was sitting in the office looking at the rain outside, and I realized that I used to love rains back in Shillong, wettest place, Cherrapunji, Mawsynram. I was thinking what can be done with water. I thought of producing umbrellas first, then I thought of producing batteries, but then batteries are harmful to the environment. Then I started thinking, what all can I produce? Then I started thinking of these kind of products where you have ABV, something known as ABV, alcohol by volume, which is 48%, 50% is limits. So half of it is water. If it is water, why can't I? And then it is distilled water. Rain is also distilled water. And the level of pollution in that part of the country is very, very less. So actually what you get is fresh, pure. So he said, I just went back. I understood that in order to do a distillation business, I needed to understand how distillation is done and what a master distillator does. So he went to Netherlands, did a course, came back, set up the industry. And then he's got fundings and all. So today, the dilemma of the case is that he has option of getting a funding of 40 to 50 million also. And he has an option of getting a funding of $4 to $5 million also. Which option should he take? And he can actually go and take a funding of 100 millions also. He has that sort of backers and investors. The problem is that if he takes 4 million to 5 million, he'll not be able to scale that big. So the kind of, and his belief was that he wanted to create a sustainable alcohol brand.
What does that mean?
Where alcohol industry does a lot of harm to the environment because they take a lot of water from the environment, one, and then they produce a lot of glass and waste also. So this is not glass. This is one thing. His water is coming from rain. That is second thing. So he's saying that problem with Shillong is, and the factories in Shillong. Problem with Shillong is it's a little sensitive region. The government has a lot of things and say and this and that. It's in the extreme corner of the country. So logistics become a problem. Now he has launched in other parts, Goa, Delhi, Haryana, Rajasthan. So logistics is another problem. And then scalability. In India is not the thing. The thing in India is still Patiala. Whiskey. Nobody understands anything about. Right? So he's like, what should I do? If I want to scale, if I want to be big, I'll have to get into whiskey. Right? And if I get in whiskey, how will I hold Cherrapunji still there? I cannot move out of the state because, so the growth, how to grow is the dilemma that is there in the case. That is why I carry it, so that I can tell people that I'm writing a piece. Okay. Fresh. Now we did not discuss statistics. You should not be bored now. Okay. Come on over it. Okay. What happened? Because people were boring.
Now we want chill.
You want? Right. Now I want you to look at box plot because box plot is something which is important. This is what a box plot is. I told you that these are vectors. Right, 25% of the data will be on these sides, 25% will be here, and then you have a median, which is quartile 2, quartile 1, quartile 3, quartile 2, and then maximum and minimum values. What does this tell you? What does this tell you? The spread here is more. Spread here is more. 30 to 45, 15 spread. Spread is 15, whereas on this side it is only 12. So in this range of 12, there are 25% of the values. In this 15 range, there are, but then these are still not outliers. You can say that the data is more spread here. More spread here. Right? So it is spread here a little more. The data is little distant from each other here. Little less here. If you look at this also, you say this is still more spread. This is less. Where do you think the mean will be shifted?
Left skewed.
It will be towards this side because the data is more spread here. So, right, it has to. 45 to 70 is how much distance?
25.
45 to 75 is?
25.
12 to 45 is how much?
33.
Answer to your question. The minimum is little on this side. That's why it is also known as a five number summary. 5 numbers. There are 5 numbers that you look at. 1, 2, 3, 4, and 5. These 5 numbers tell you a lot about the data. These 5 numbers tell you a lot about the data. Now, this is already done. Let us talk about. I actually wanted to bring cards today to the class. I forgot. I would have done things with cards. Let's do one simple game. You want to play a game?
Yeah.
Have you heard about Monty Hall problem? Monty Hall problem? Okay. There are 3 doors. 1, 2, and 3. 1, 2, and 3. Behind 2 of the doors is gold. And behind 1 door, there's a brand new car. Ferrari car. Red color. Door number 1, door number 2, door number 3. The game starts. All of you have to choose 1 door in your head.
From that movie, right?
Movie में भी था, game भी था, एक reality show भी था. But we'll be looking at the logic. It is not a random game. It is not a mind game. It is a game of mathematics is what I will be showing you today. And some of you will not even believe it. But then I'll try and make you believe this. Chosen a number, right? 1, 2, 3. 1, 2, 3. Which one do you pick? Okay, how many of you are picking 1? I'll go with the majority. Only 1 person. How many are picking 2? 1, 2, 3, 4, 5, 6, 7. How many are picking 3? 1, 2, 3, 4, 5.
Random, ऐसा कुछ नहीं.
Random क्या था? चलो ठीक. Most of the people have gone with 2.
Same probability.
Now, let's say that this is the case, door number 1. Same probability is the question. 2, 3. Most of you have picked 2, so I am going with the popular choice of the class, that is 2. As soon as you say 2, right, I tell you that we have chosen 2. There is a goat behind gate 3, and I open the door and show you that there is a goat. Here. Done. I've shown you a goat. Now only these 2 are left. And I'm telling you now, I'm giving you an option. Either you can shift from 2 to 1, or you can still stay with 2.
Yes.
Will you shift or will you stay?
Yes.
Think for 5 seconds. Think for 5 seconds. Thought? How many of you, I want your hands, how many of you will shift? 1, 2, 3, 4, 5, 6, 7. 7 of you will shift, that means 7 of you will come here. How many of you will not shift and say that irrespective of anything, it remains the same? 1, 2, 3, 4, 6, 7.
I mean, I chose door one.
सारे online वालों को भी.
I chose the door 1 only, so.
We saw it.
No. Arey Baba.
No one assumed that.
Okay,
Assume
sure.
you all chose 2.
Not shift.
Not shift.
Let's say 7, 7. Now, I want logic from people who have shifted. Why?
It improves probability to 67% once you've shifted.
How many of you are agreeing to this?
What? That's the thing. So I know.
That is how it goes.
That is how it goes, Adit.
Basically,
ये scenario है उसमें
Just
either you consider it as
Now,
50-50 or
okay,
your initial.
let's think together. Earlier when you made this choice, what was the probability of you winning?
33%.
33% when you chose this, so there was a 33% probability here, 33% probability here, and 33% probability here. As soon as I told you that there's a goat behind this, will this remain 33, or will this change to 50-50 now?
66 and 30.
You're saying that this will become 66?
This and this.
This will become 67.
Yes. Because 3 and 1 were together 66.
And you'll say this will still remain 33.
हो सकता है 33.
It's only out of 2.
Basically, what happens is when I chose 2, when basically we chose 2, we had 33% probability of being right and 67% probability of having the car in the other options, whichever option that was. 1 or 3, we don't care. So nothing has changed. Basically, still there is 67% probability of we being not right. And that is now all now collated into one door, which is door number 1.
नहीं, आप starting से देखो.
So basically,
Independent event.
now you know that there is a goat behind 3, but fundamentally what has happened is you had only 1 out of 3 options to
So
choose from.
independent events.
He's saying it is independent. चलो एक और काम करते हैं. रुको.
It happened.
एक और काम करते हैं. Let us change. Let us hold this for some time. What you are saying, to me, it sounds logical. Maybe. But if I have to show it to him, I will do another experiment. Let us do one more experiment. Let us forget this for some time. Let us say that I have a deck of cards.
कार्ड कितने में जा रहा है?
कितने हैं मेरे पास में? 52. I tell you that if from this deck, if you pick ace of heart, you win. And I'll give you 1 billion. Right? You can pick any card. Now you pick one card. लो card उठाओ. अबे card उठाओ. What is the probability of that being an ace?
1 by 52.
1 by 52.
Ace की
Ace of heart.
Ace of heart.
1 by 50.
तो
Yeah.
वो
लाल.
रिप्लेसमेंट या नॉन रिप्लेसमेंट वाला आ गया कॉन्सेप्ट उसमें.
नहीं आया भाई वो यहाँ से नहीं आया. सुन तो ले. Now you have 1. I have 51 in my hands. Now I shuffle them. I know where the goat is. I know where the ace is. Is it in your hands or my hands? I don't reveal, but I know. I'm the one who's making you play this. You, as a person who is unaware of these things, will only be taking decision on the basis of what is there. Now, your probability of having that ace right now in your hand is 1 by 52. I open one card and I show you that this card is not an ace. I show you another card. 3rd, 4th, 5th, 6th. As I am opening cards one by one, the probability of that card being an ace of heart remains the same. Because he has already chosen it, he has locked it. That card will not be changed. But the ace being here is having a probability of 51 by 52. As I am opening the card, this probability is going up.
The next
Right?
card can be ace.
As I keep opening more and more cards, the probability of ace 1 by 51, 1 by 50, 49, 48, 47, 46, 45, 42. It comes to an extent where it is 1 by 10 now. I have only 10 cards. One is with you. Your probability is still 1 by 52. The card that he had in his hand is still 1 by 52 because it was chosen then. My probability is changing. Why is it changing? Because I am opening these cards and now the ace being here is getting higher and higher. I open all the cards. Now I have only one card in my hand. Now I have only one card in my hand. I give you an option to either switch or not. What will you do? Switch. Why? Because now you are saying, what was the probability when it started? Your probability was 1 by 52. What was my probability? 51 by 52. So my friends, the probability that the last card is an ace is 51 by 52, not 50%. 51 by 52 is almost 1. You would want to switch. Yes or no?
Yes.
भाई साहब अपन को नहीं आया. मैं
Last
सबको
card.
देख के बोला.
So है तो भावना है ना finally.
There is a difference when you say that the probability is like
No.
probability of last card is 51 by 52. I get that, but probability of me having that, just if you compare it with that. For example, the question is whether, like, I've taken one card. Now 51 card you have. I have one card. Right? There are total 52 cards. Now we have to find out what is the probability that the card is with you or me. That is the question that is being asked.
This is
with
the card that is there in your hands. These are the cards that are there in
Yeah.
my hands. अब बताइए.
The question is, where is the card now?
हाँ.
The question is, where is the? So the question now.
The probability is still what? 1 by 52. अगर हम ये exercise 52 बार करते हैं, if we do this exercise 52 times, you will win 1 times. This is what probability says. The probability of getting 3 on a dice is what? 1 by 6. That means if you roll the dice 6 times, you will get 3 1 times. This is what it says clearly. It is 1 by 52. If I do it 52 times, he'll get it 1 time. But I'll be having it 51 times in my hands.
Fine. So the question that once we have two different spaces, like one card is there, 51 is there, the question that we are essentially asking is where is the card? Then it means there are two places where the card can be.
Yes.
Either here or there.
Yes.
So I'm not going into individual card, no. I'm saying now the question essentially when you go to the doors is where exactly is the whatever was the goal or
So
card.
basically, so what is happening is the original choice when you made it.
in a different manner. I know a lot of probability games. We are playing Russian roulette. वो वाला
What खेले?
रूले खेले तो
I give you two options. One is a gun, a revolver that has 6 bullets in it. The other one that has only 1 bullet in it. What you are telling me essentially is, sir, ये चुनो चाहे ये चुनो.
अगली गोली तो लग ही
बात तो
सकती
वही है sir.
But the question is
आपके क्वेश्चन में आंसर है.
मैं ये कह रहा हूँ कि once I've taken out one card, there are two places where the card can be. Now we have to decide either it is here or
One
here.
place to. These are the two places where the card
So
can
one
be.
by two हो गया ना.
हाँ सही
दोनों में से एक ही जगह बुलेट था.
Question ये है कि कहाँ से
second question again. That's different.
यहाँ पे second question is like
Right.
how?
Probability works like this, I'll tell you. Probability works like this. The chance of an event occurring. Where is the chance higher?
But इसमें तो full deck है ना.
Question क्या है?
Question is bullet किसमें है?
मतलब the
Question you are answering is fire करने में bullet कब आएगी?
किसमें happening वाला है वही तो question है.
No.
You're asking the wrong question. Sir is saying basically there is more chances of that bullet
Coming out.
when you do it 10 times over. When you do it 20 times over.
Forget 10 times, 20 times. One time only. Where is the higher? Which one has a higher chance of having the ace?
First one.
So will you choose one or two? If you have to bet here, let's say the bet is 100 rupees between you and
It
me.
is more in one, right? But when we are going into the door question, वहाँ पे
मैं वहां आऊंगा.
ठीक है. One.
One. So you will bet on one. Now what I tell you is, you have chosen this already. You have put your bet on this. Let's say you have put your bet on this. I gave you an option. You chose a card. Your bet is 100 rupees that this card is a ace of a king. Oh, sorry, ace of a heart. Ace of a heart, whatever. Now, if you win this, I'll give you 1 billion. If you lose this, I'll take 100. Right? Now what I do is the rest 51 cards that I have in my hand. 1, 2, 3, and 2, 151. I open one card. I show this to you and I tell you, see the 51 cards that I had in my hand. Out of this, I'm opening one card and this card is not ace of a heart. This is something else. Okay. I ask you, would you now want to switch with some other card or will you still have this card in your hand? What you will tell me is that I don't know. I am not able to decide right now. Because it is not clearly evident what is happening. Now I'll tell you when the things will become clearly evident. I open one more card. I open 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. I have opened 20 cards. I'm left with, I started with 51. Now I'm left with only 20 cards. 10 cards. 1 card. Now I have only 1 card in my hand. And you still have this very card that you drew first time. What is the probability of this card being an ace? Is it 1 by 2 or is it 51 by 52?
51.
Sir, when you ask that question again, that do you want to switch doesn't the probability reset?
No.
It is between two cards. Right?
Starting so.
I am not shuffling or I am not doing anything. I am just giving you an option either A or B and you've chosen this already. You've chosen this already. This is not changing. See, I'll tell you where the play is. I would have loved to do it in the class actually 10 times. And I would have shown that all the 10 times I will win. If I'm doing it 52 times, I'll win 51 times. You can actually do it in, I wanted to bring the cards. But what you need to understand here is, I know which one out of these 51 is the ace. I know which one is an ace. Out of 52 times, 51 times the ace will be in my hand, one time it will be in your hand. This you understand? Out of these 52 chances that I am doing, I every time purposefully show you the cards that are not aces and I keep the ace in my hand till the end. Right? What is the chance of this card being an ace? Because I know all the cards. I know where the ace is.
I know.
It is 51 out of 52 times that this is an ace because I am holding it close to me. The question is, how many times will you switch? You will switch 51 times because one time to you will also be having it in your hand. Even if you know.
But you know it, na? Then
That's what I'm saying, Baba. If you don't know, the logical thing to do is switch. Because if you're switching, the chances of winning are 51 by 52, right? And the chance of losing will be only 1 by 52. The probability of this has not changed. The probability of this has changed with every card opening up. Are you guys getting what I'm trying to say? Now you bring this back to the previous example where my friend was trying to explain the same thing. Where he says, initially, when this was the case, 1, 2, and 3. Now, let's say that the goat is actually here and here, and here. This is a car. Let's say, possible. You have chosen gate number 2, right? Irrespective of what gate you would have chosen, I could have shown you a goat. If you would have chosen 1, I would have shown you a goat. If you would have chosen 3, I would have shown you a goat. If you would have chosen 2, I can still show you a goat. I can show you a goat every time. The chances of you winning right now out of these 3 will be 33%, and the chances of you losing is 67%. Yes or no? Just like the chances here, the chance of you winning was 1 by 52. The chance of you losing was 51 by 52. As soon as I open a gate, I know where the car is. What I've done for you now is the chance of losing that was in 2 gates. I have brought it down to only 1 gate. That means if you switch, you will win 67% times. If you will switch, you will win 51 by 52 times. Right? So your chances of winning will be higher now if you are switching. Do one thing, right? Go back home. Talk to ChatGPT. No. ChatGPT works here. Go to ChatGPT. Ask them to create a simulation for Monty Hall.
You'll find it online.
करके देखो करके ChatGPT से खुद बनाओ. Ask ChatGPT to create a simulation for Monty Hall problem. Don't use the online version. You do it with ChatGPT, and then ask it to play this game 100 times and see how many times it is winning and how many times it is losing when it is switching. It will be winning around 67, 66, 65% of the times when it is switching, and will be winning only 33%, 32, 31% times when it is not switching. Go back home, play cards with your siblings, friends, amongst yourselves. You are staying in hostels? Do this with cards. And you will find out. Now, why did we do this in class? Why are we discussing this? Probability I can sense that all of you understand. Right? If I am asking you questions like, what is the probability of getting a number which is 3 and above on a dice? You will tell. Right? What is it?
2 by 3.
3 and above.
2 by 3.
2 by 3. Right? 3, 4, 5, 6, 2 by 3. Wonderful. So you say, oh, everybody is getting how? 3 and above, 3, 4, 5, 6. We need only this much of probability mostly in distributions and all. Right? Now, if I ask you one more question. Who has the smallest name here in the class? Kenny. Let's say Kenny. Kenny is good. Sapna is also good. Kenny. How many words can you form with these letters that you have in Kenny?
60. And acha words.
How many possible distinct words can you have with Kenny?
5, 4, 3, 2,
The
1.
words that make sense or the
No. Need not make sense. Need not make sense.
60.
120.
5 factorial. Upon 2 n दो बार है. Permutation है ना matter plus 5 factorial.
So you're saying 1, 2, 3, 4, 5, and you're going to do this completely.
Divide by 2 factorial भी हो जाएगा.
2 factorial की जरूरत नहीं है ना.
n दो बार है ना.
क्या कर रहे हो तुम?
n दो बार है.
Okay, let us.
रिपीट हो रहा है भाई.
Divide by 2. 5 into 4 into 3.
एक बार. There's this comedian Subramaniam. What is his name? Rahul Subramaniam. MDI pass out. He came to my institute for a comedy. There was a junior of mine. Little enthusiastic of that specifically.
पुनीत भी है हमारे में भी है.
Rahul Subramaniam, I'll tell you a joke. And he's like, ha ha ha. Was it funny? Is it very funny? Do you think that you can do better comedy than me? He said, yes. You know what he said next? He said, remember who is getting paid. So in the class, when you talk, remember who is getting paid to talk. Okay. When I ask to stop, stop. Okay. Let us say that there are 5 numbers. 1, 2, 3, 4, and 5. How many different digits can you make? Let's say it's a log, combination log, where I tell you that the numbers are between 1 to 5. How many possible combinations can you have? If I tell you that you are allowed to use any number of times, then in this case what happens is
5.
you can put 5 numbers here, any number out of these 5. You can again put 5 numbers, you can again put 5 numbers, you can again put 5 numbers, you can again put 5 numbers. Yes or no?
नंबर तो
आई मैं जानता हूँ तू उस पे अटका हुआ है इस पे उधर आएंगे इट इज फॉर एवरीबॉडी 5 raised to the power 5 is the possible number of passwords that you can generate with these 5 numbers. Now if I tell you that you cannot use these multiple number of times, if you have used a number once, you cannot use it again. Then comes the other case where my friend was telling that you will have 5 here, you can take any of these, then the next will be 4. You can, let's say you've taken 2, then you can take only these 4. Let's say you've taken 3, so you're left with only 3 possible options. Let's say you've taken this also, you're left with only 2 possible options. Let's say you've taken this, then you'll be left with only one option, which is 5 into 4 into 3 into 2, 1 to 1, which is 5 factorial. Everybody is okay with this?
Yes.
Because in this, all the numbers were distinct and not same. That is why you had these many. If there would have been a number which was same, and I would have told you that this is the case, then what happens? Let's do it with a smaller example. First, let's say there are numbers are 1, 1 and 2. How many distinct numbers can you form with this? Right? Here, only 2 numbers can be there. Right? Either you will put 2 or you will put 1, and then you put 1. Then you don't have an option, you will put 1 again. Right? Here, again, if you have gone ahead with, let's say 2, or let's form the combinations. So what are the combinations possible? 1, 1, 2, 1, 2, 1, and 2, 1.
1.
Is there any other possible combination that you have? Right? Here you had 2 possible combinations that you could have formed here. There was 1 possible combination here, and then there was 1 possible combination here. Now, if I want to look at this in a logical manner, how do I say? Out of these 3 numbers, I can put any number here, and then 1 number here. Any of these, if these would have been distinct, I would have got 6. But how many am I getting? 3. So there has to be some relationship between 6 and 3. What should 6 be divided by so that I get 3? 2. What is this 2? The number of numbers that are getting repeated. So let's say if the numbers would have been 1, 1, 1, 2. Right? How many distinct numbers can I get? So I'll use the same exercise. 4, 3, 2, 1. 24 are the possible numbers if these would have been different. But out of this, there are 3 numbers that are same. So 3 factorial. Divided by factorial. That will be 24 divided by 6, which is 4. So 4 distinct numbers you can form. You want to check? Actually, you can check. It will be 2, 1, 1, 1, 1, 1, 2, 1, 1, 1, 1, 2, 1, 1, 1, 1, 2.
2 can be put
2
in.
can be put in 4 different places, that's it. So 4 numbers. So the formula becomes simple. Now let's talk about Sapna. And then we'll talk about our friend Kenny also. Sapna. How many possible words can you form? With meaning, without meaning, whatever.
5 to the power
5 factorial. So 5 into 4 into 3 into 2 into 1 divided by?
120 divided.
What is getting repeated? Divided by 2 factorial or 2?
Same.
60.
Can he say?
Sapna. What is happening with Kenny?
Same.
Kenny is same, right? Things are good, clear, no problem at all. We are all fine here, right? पता नहीं कैसे बदलने का हाथ रखा जाता है. We'll do it again. You tell me. Cat. C-A-T cat. How many distinct C-A-T cat? How many distinct words can I form with cat? How many letters are there in cat? I should 4, but she was attentive. So 3. I can put either C or A or T here. But if I've chosen, let's say 1, how many am I left with? 2 more. And then if I've chosen 1 more, how many am I left with? So the total possible is 3 into 2 into 1. The idea is to make you aware of something which is known as a factorial. What is a factorial? N factorial. N factorial means
into n minus.
any number. Let's say 3 factorial means what? 3 into 2 into 1. What am I doing? I am reducing 1 every time and multiplying. N multiplied by n minus 1 multiplied by so on. It will keep on doing till the time I get 1. That is factorial. Now there is a game of permutation and combination where you have arrangements and choosing things, right? Now, arrangements are like this. Sorry, arrangements are like this, where you can put anything anywhere. Where you can put anything anywhere. Combination is simply choosing things, right? Now, let us say that we are talking about, I want to choose 4 out of 5 people. 1, 2, 3, 4, 5 of you are here. I want to make a team. I want them to play Ludo. If I want you guys to play Ludo, in how many ways
5.
can I choose a team? Out of 5 people, the question is clear?
Yes.
There are 5 people that are sitting in the class. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Out of these 5 people, I have to choose 4. In how many ways can I choose these 4 people?
5.
How do you get to this? So whenever I say I want to choose, I say N, C, R. And whenever I say I want to arrange, I say N, P, R. This is permutation and this is combination. We are not doing 11th maths. My idea is just to, I don't want you to be experts in probability or permutation combination. I just want you to know these terms so that when I use them later, maybe you guys will make sense of what I'm doing and why am I using this formula and writing this formula. Now, what is N and R here?
N is
N is the total number of people that I have. What is the total number of people? R is the total number of people I want to choose. Very simple, right? Combination is total number N, whatever I am interested in R. How will I write this?
5C.
N factorial divided by N minus R factorial multiplied by, let us see if this works. Let us see if this works. I might be wrong. Let us see. What will this be? N factorial is what?
5 into 4 into 8.
5 factorial divided by 5 minus 4 factorial is how much?
1 factorial.
1 factorial, which is 1, multiplied by 4 factorial. What do I get?
5 into 4,
5 into 4 into 3 into 2 into 1 divided by 1 multiplied by 4 into 3 into 2 into 1. I can directly do this and I get 5. Is this formula correct? Now, why did I get to this formula? Okay, I'll tell you how did I get to this formula. Let us also talk about the permutation formula first. What is the formula for permutation? N factorial divided by
n minus r factorial.
n minus r factorial. What is the difference between these two? Only this r factorial is extra. Only this r factorial is extra. How many ways can I arrange these 5 people? All of you have answered it multiple times already. 5 factorial. Right? How am I getting to this? 5 factorial divided by
1.
what is r here?
5 minutes.
What is r?
That's 5 you're arranging all 5 people.
R is 5. I have 5 people. I am arranging all 5 people. If I am arranging all 5 people, 5 minus 5 is
0.
What is 0 factorial?
1.
Please remember this. 0 factorial is equals to 1 factorial is equals to, and then on you go with multiplication and all. Right? This will still remain 5. What if I tell you that I want to arrange 4 out of these 5 people? I have to arrange 4 out of these 5. How will I do it? 1, 2, 3, 4. 5 into 4 into 3 into 2. Here I can put any one of these. In the second number I have 4, then 3, then 2. If I am using, let's say, Rivka, Rivka, how many 3-letter words can I form with Rivka? Rivka is her name.
Yes.
वो ऐसे हंस रहा था जैसे मेरे को बताओ।
मैं अभी हिला तो वहां पर मुझ पे फ्रेम होने लगा बस।
If the frame is on me, I should better be seen as smiling person. There might be.
5 into 4.
Haji. So the question was, how many 3-letter words can be formed with Rivka? In the first letter, I can have any of these 5. 5. In the second one, I can have. In the third one, I can have 5 into 4 into 3. Let us see if it works in our formula. I want to have 5 P3. Out of these 5 letters, I want to form 3. Arrange only 3. Let's see. 5 factorial divided by n minus r factorial. What is n minus r? 2 factorial. 5 factorial divided by 2 factorial will be what? 5 into 4 into 3 into 2 into 1. Divided by 2 factorial. It's 2 into 1. That is this and this. We get 5 into 4 into 3. Formula is working fine. Yes. Yes, sir.
Yes.
Now, the only difference is here when you're talking about selecting, 3 out of 5, there are 5 people, you're selecting 3 out of 5. You don't talk about changing their positions. Where were you getting this extra R from? Why have you put this extra R? Because you are also involving their position change, which you are not involved in. ये तो 3 लोग आप लेके आए भाई साहब, ये वाले जो आपने 3 लेके आए, इनमें भी तो आपने अरेंजमेंट्स लगा दिया ना, 5 into 4 into 3 किया ना आपने, 3 into 2 into 1 तो नहीं किया आपने. When if you would have talked about only selecting 3 people out of 5, how will I select 3 people out of 5? How will I select 3 people out of 5?
Let's see 3 first.
बताइए. So I told you I would play Ludo. That time I told you I would play Ludo with these people. You said कि अच्छा तो आप 4 को ले रहे हैं कि नहीं को? तो आप इनमें से ये वाले तरीके से ले सकते हैं. Let us say I will take only 3 people out of this. How will I take 3 people?
5C3.
5C3. What will be the formula? What will change? This will become 5 minus 3, 2 factorial. And this will become
3 factorial.
So this will cancel out from this. So it will be only 5 into 4. Right? 10. There are only 10 ways in which I can select these 3 people out of 5 people without repetition. Will you remember this NPR and CR? What is the formula for NPR? I don't want you to remember the formula, but I just want you to understand what is P. P is possible arrangement. P is selection. Come back to probability. Why am I mixing this and probability?
Probability of it goes hand.
Logic नहीं होता भाई, very much. Clear. अरे हाँ. बस I take 5 more minutes. I have 5 minutes. How many of you are comfortable with sets? Set theory, set.
नया बोल गया
So now,
No. सबसे दुनिया का आसान एग्जांपल बोर्ड पे एक दो there are two examples that are the easiest to talk about in probability or dice. One is coin, other one is
Nice.
if you want to make it a little more complex, what will you bring? So coin, dice and mix of this one. Why have I called it mix of these two? Cards and deck.
Sets.
C&D.
Head
Deck of cards. CD and now head and tail. You will get either head or tail. Can you get both?
No.
Events which will be either or will be known as mutually exclusive. Either this will happen or that will happen. If I select a student in this class, either that student will be a male student or a female student. Male and female is mutually exclusive. Now, when I am saying mutually exclusive, there's one more thing which I say.
Collectively exhausted.
I come to that. If I say you have heard about union and intersection.
Yes.
What is union and intersection? Simple सा एक काम करते हैं. मानते हैं कि एक पूरी क्लास है भाई साहब. इस क्लास के अंदर ये गर्ल्स हैं, ये बॉयज हैं. ठीक है जी, कोई दिक्कत नहीं है, right? If I say that union of girls and boys, union combining girls and boys will be a universal set, will be a set that includes everything. Very good. Intersection of girls and boys is a null set. कोई भी ऐसा नहीं है जो कि गर्ल एंड बॉय दोनों होगा, या फिर कोई भी गर्ल बॉय नहीं है, कोई भी बॉय गर्ल नहीं है. So this is if I add G plus B, I get the universal set U. If I talk about, so this will be union, okay? If I say that what is the intersection, I get a null set which is कि भाई दोनों में कुछ आ रहा है, कोई भी ऐसा नहीं है जो दोनों में आ रहा हो, right? Head and tail, similarly, head and tail together will be, will include everything that is there, all the possible cases, so it will become collectively exhaustive. If you include them collectively, they'll exhaust all the possible options that are available. Collectively exhaustive. Mutually exclusive. हम दोनों एक दूसरे से तो बात नहीं करते हैं, बट जब हम दोनों मिल जाते हैं तो सब कुछ आ जाता है, right? Let's say odd plus even on a dice. Will there be any number which is odd and even both? So they are mutually exclusive and collectively exhaustive. But if I tell you prime numbers plus odd numbers, will this be mutually exclusive and collectively exhaustive? No. Why? Because there are prime numbers that are odd.
Yes.
And there are numbers which are outside this even. So this is not mutually exclusive and collectively exhaustive. Deck of cards. ये जो hearts है, club है, diamond है, spades, whatever. बहुत सुंदर बनाता हूँ. हाँ, समझ आ रहा है. These are all together mutually exclusive, collectively exhaustive. Face cards, non-face cards, mutually exclusive, collectively exhaustive. But if I talk about even odd, in this case, might not work. Even कुछ cards दो 12 है. Queen को 12 भी बोलते हैं. That will be even and face card, right? You got the concept of mutually exclusive, collectively exhaustive. इसी के साथ डिस्क्रिप्टिव स्टैटिस्टिक्स की मोटी बातें. आप लोगों को क्या करना है? असाइनमेंट क्या है घर पे? You will read about biases. You will do simulation on Monte Hall. Monte Hall, Carlo नहीं. Monte Carlo मत कर देना. Right? You will do this, that, and you will do one more thing. You will go through these slides till. मेरे को ना मजा आता है कई बार. 100.
Shit.
Maybe the next class.
Next week.
35 slides.
And give me 2 more minutes. Our friend sorted the data for the class. ठीक है जी, ये आपका क्लास का डेटा है.
सर ये डेटा में कुछ नहीं है सर, 35,000 लोगों का डेटा है हमारे पास. हमें ना 35,000
वो चाहिए, वो डेटा किसी के पास नहीं है.
We'll work on that also.
वो डेटा किसी के पास नहीं है. वो डेटा एडमिन के पास है. एडमिन से ले लेना, आप इंसान के पास है.
मैं नाम बोल रहा हूँ. मुझे बताया था कि 35,000 बच्चों में से हमारा सिलेक्शन हुआ था, तो हमें वो
डेटा ले स्टूडेंट है वो.
35,000 सेल्स फॉल है भाई.
तुमको इस चीज का
हमें देखने कैसे हुआ.
फंड है या फिर इसकी?
हमें नहीं
हमें उसका स्टैट्स जानना है.
$10,000 sales call.
You're saying that you leave.
Who's saying?
Okay, quickly. Now see, I tell you, if you've got the plugin that I was talking about, in the data tab, you will get data analysis here. In today's class, we talked about, so you're seeing what I'm doing, right? You go to the data tab. In the data tab, you have data analysis. Go to data analysis, find descriptive statistic here.
थोड़ा सा लेफ्ट कोवेरिएंस के नीचे वो डी में अल्फाबेटिकल है.
Wow, so input range. So this is my input range. Age data. I've selected all 48 students, grouped by columns and all is fine. It is all grouped by columns only. I have label in the first row. Yes, I have. I want the output here only in this sheet itself. Let's say I am selecting it here. And then I say that, give me summary statistic. We'll talk about other things later. See, this is what you get. Now, you have mean, standard error, median mode. You have standard deviation also. Now, standard deviation is 3.4. With this standard deviation, I can very easily find out what will be the probability of finding a number with this and whatever, right? I know that 68% will be 1 plus 1 standard deviation plus minus with the. Sorry?
हॉस्पिटल में होते तो तुम बोल जाओ.
चला गया सर क्लास से.
मतलब फोन हाउ फोन करियो तो हाउ का करना है क्यों. Apologies sir, apologies.
शशांक की फोटो पे देख के.
Okay. Now you get mean, median, mode, standard deviation, variance, kurtosis, skewness, everything from here. Range is also here. Maximum, minimum values are given. So you've got everything at once. Now I'll give you an assignment. This is one. And another thing that is of importance for us is, you see this insert tab?
Yes.
In this insert tab, you will also see. What happened? You'll also see some charts here. You see these charts? Right? In these charts, you will have column, line, pie, bar, area, XY scatter. I told you that I tell you what scatter chart is like. Scatter chart is nothing. If you have X and Y, X and Y. Let's say X is the year and Y is the rainfall, right? So with each passing year, you will have rainfall data. So this is the scatter plot, right? Now, what you have to do is, I'll give you an assignment. Histogram, box and whisker. Box and whisker, all of you know what is box and whisker?
Yes.
Now you have to go back and select, and you have to download YouTube data, the number of followers. So you have to find out the channels on YouTube with the highest number of followers. Get a list of top 100 YouTube channels. List of top 100 YouTube channels today, or the latest that you can find. Find out all the descriptive statistics about the top 100 YouTube channels in terms of their followers. So you'll have one column where you'll have the number of followers for each of these channels. You find the mean number of followers for 100, median, this, that. Find out whether there is skewness in this data or not. Top 100. Then you also see there's category given. Categories given, right? What category is it coming from? Is it a kids channel? Is it an informative channel? Is it a text channel? It's a vlog or what? And find out that the data that you have, if there's any other data that you're getting, find out whether the data is categorical or ordinal, nominal, right? Whether the data is quantitative or ratio interval. Think about the data that you're getting. What kind of data is it? Is it continuous, discrete? I will not tell. Number of followers, you can think about it yourself. Categorical, whether it is rank ordered, not rank ordered, whatever. And then have at least 5 charts drawn out of these. It can be histogram, it can be pie chart, it can be box and whisker, it can be a bar chart, it can be anything, it can be scatter plot, whatever. At least have 5 charts and make sense out of it. Make sense for yourself. I will not ask you to submit it, but I might ask anyone to present it on the screen. And then we'll see how are we differing, what all one could have done and what all have you ended up doing. When I talk about statistics, statistics is the simplest part. Descriptive statistics, select the entire data, find out, and then try and make sense out of it. What if the skewness is positive, negative, kurtosis is positive, negative, what is happening, what sort of data is it? What do you understand from this? One more option. If you don't want to do that, don't do that. All of you are in Gurgaon, people who are in Gurgaon specifically, you look at the ratings of the top 20 restaurants around you on Swiggy or Zomato, and then do the same for that as well. Whether the category of that restaurant is a fine dining, it's a QSR, it's a cloud kitchen or whatever. How will you find out the top 20? Right? Just near you, go through the restaurants that you have. Dana Choga and all has 80,000 something, so you just find out how many reviews one restaurant has got and do the same analysis on that as well. Okay? Or if you think of anything more creative or anything that you want to do, you can do that as well. But the idea is you have to do descriptive statistics. You have to talk about few of these pictorial and graphical representations of the data. Is it okay? Clear? 3 assignments?
3 or?
Yeah, 3.
4. No.
Biases?
1 out of 3 or 3 out of 3.
Biases? This one?
Monty Hall.
Monty Hall?
Slides.
Slides. That is not an assignment. That you have to do. Otherwise, how will you survive?
Yes, sir.
Now you must be thinking, why is he asking us to do so much? जल्लाद किस्म का आदमी है. भाई हमारे पास टाइम कम. Did you already know 50?